Today I'm going to take you on a hardware tour of the Sega Mega Drive PAL-1 model 601-11. The Sega Mega Drive derives its power from an external power supply brick which delivers 10 volts at 1.2 amp max and it plugs directly into the DC input sockets on the rear panel of the machine. On the inside of the machine, the power supply is handled by two 7805 CT voltage regulators which are mounted to a rather sizable heatsink, and these voltage regulators regulate the 10 volts DC input to 5 volts DC. Now taking a look at the Sega Mega Drive's block diagram, I've marked voltage regulator number 1 with a blue circle and voltage regulator number 2 with a red circle. And what you notice when looking at the block diagram of the Sega Mega Drive is that they've distributed the outputs of the two voltage regulators very evenly throughout the system. And I would think this is a combination of wanting to reduce interference between the various components within the system, noise that they might produce, and as well distributing the output of the voltage regulators so that neither of them gets too much current drawn from them. I'm going to start off by taking a look at the system's main central processing unit, which is a Motorola 6800, which is packaged in a rather large dual inline package. This picture shows the exposed die of a Motorola 6800, and taking a closer look at the CPU die, you'll notice that it's a 1979 vintage. The 6800 is the first implementation of the 6800 16/32-bit microprocessor architecture. The 6800 has a 16-bit data bus and a 24-bit address bus, while the full architecture provides for 32-bit address and data buses. The resources available to the 6800 user consist of the following: 17 32-bit data and address registers, 16 megabits direct addressing registers, 56 powerful instruction types, operations on 5 main data types, memory mapped I/O, and 14 addressing modes. Next I'm going to cover the 315-5433. This is a custom chip made by Sega, and the 315-5402 chip is an integration of the 315-5309 and the 315-5364, which I'll cover later. The chip that's in this machine, being the 315-5433, is the same chip, but it also contains the TMSS ROM. The 315-5309 is a memory map peripheral mapped into memory, and each address described below allows access to a specific register within the chip that can control various aspects. The 315-5364 is the bus arbiter / 6800 address decoder found in later Model 1 Mega Drives. In essence, it's simply an integration of the 315-5308 and the 315-5345 into a single chip, presumably to make the board easier and cheaper to manufacture. Its primary purpose is to act as a bridge between the 6800 and the Z80, providing the Z80's clock and reset lines, as well as chip selects for its various periphery. It also holds the Z80's bank register used to select the appropriate 6800 bank, whose address this chip puts on the bus during free cycles. As the 315-5364 does not have enough pins to complete the Z80's address or data bus, it uses the 315-5309 to handle additional Z80 bridge duties, namely bridging the lower address bits and the data bus between the 6800 and the Z80. Next I'm going to take a look at the system's main memory, which consists of 64 kilobytes of memory divided across two 32 kilobyte TC5183-2 P-12 memory chips. These chips are packaged in dual inline packages. The TC5183-2P is a 256 kilobit high-speed CMOS pseudo-static RAM organized as 32,768 words by 8 bits, and has the following features: organization of 32,768 words by 8 bit, fast access time and cycle time. I've encircled the appropriate timings for the chips found in this machine in red. Single power supply at 5 volts plus minus 10%, static RAM-like write function, all inputs and outputs are TTL compatible. It also has low power dissipation, and for the TC51832P-12 it's 220 milliwatts. Standby is 5.5 milliwatts. Self-refresh is also 5.5 milliwatts. It has two types of refresh operation capability, auto-refresh and self-refresh, and it's pin compatible with 256 kilobit CMOS static RAM TC55257P. Next, I'm going to take a look at the system's secondary processor, which is the Z80. This processor handles the system's audio, and it's also packaged in a rather sizable dual inline package. And here's a die shot of the Z80. The Z80 has the following features. It has an extensive instruction set containing 158 instructions, including the 8080A instruction set as a subset. It comes in two versions, an NMOS and a CMOS version. The NMOS version is for low-cost, high-performance solutions, and the CMOS version is for high-performance, low-power designs. The type of Z80 found in the Sega Mega Drive is the NMOS version, and it's clocked at 4 MHz. Next, I'm going to take a look at the Z80's memory chip, which comes in the form of an NEC PD4168 memory chip, which is an 8192 word by 8-bit NMOS XRAM, and it's designed to operate from a single plus 5 volt power supply. Next, I'm going to take a look at the 315-5313. This is another custom chip made by Sega, and it's essentially the system's graphics chip. Here's a rather rare die shot of the 315-5313, and this image also shows the various pinouts of this chip. The system's frame buffer consists of two NEC PD41264 dual-port graphics buffer chips. Next, I'm going to cover the system's RGB encoder, which is a Sony CXA1145P chip. It's also packaged in a dual inline package and has the following features. It features a single 5 volt power supply, low power consumption being 110 milliwatts. It's compatible with both NTSC as well as PAL systems. It's got a built-in 75 ohm driver for RGB output, composite video output, and composite sync output. It also has a built-in oscillator for subcarrier, and an external input of subcarrier is also possible, and it also has a built-in audio buffer circuit. Next, I'm going to take a look at the Yamaha YM2612. This is the chip that's responsible for the system's iconic sound, and it's also packaged in a fairly sizable dual inline package. The Yamaha 2612 frequency modulation sound synthesis IC resembles the Yamaha 2151 used in Sega's coin-operated machine and the chips used in Yamaha's synthesizers. And its capabilities include the following. It has 6 channels of FM sound, an 8-bit digitized audio channel as a replacement for one of the FM channels, stereo output capability, 1 low-frequency oscillator to distort FM sounds, and 2 timers for use by software. Next, I'm going to cover the Sony CXA1034P. This is a stereo amplifier chip which can output or drive 2 channels at 0.03 watts, and it's used to drive the headphone jack situated at the front of the machine. Next, I'm going to cover the LM358N, which is a low-power dual operational amplifier, and this chip is used to drive the audio component of the AV output. And lastly, the machine is also fitted with an RF modulator, which is situated within a metal shielding below the heatsink towards the rear of the machine. So the next time you're playing a good old game of Sonic the Hedgehog, just remember how much is going on behind the scenes to make your gaming experience possible. I hope you enjoyed the video, and thanks for watching.